Yeah, let's get RevoltRise in here. Woo woo woo! Where are you on my list of people? Here you are. All right. Anytime you're ready, you can call. John McCain is a criminal and a war hero and criminal. Uh, all right. Hey there.
Hello.
How's it going?
Going well.
Having a good day?
Yeah, something like that. I just finished up working and I'm a little flustered at this second, but I'm ready to go anyway. Let's do it.
Okay.
Hello.
Like good flustered, bad flustered?
Oh no, just like in a flurry of like closing things out at the end of the day and like I'm whatever. Had to pull the trigger eventually and clock out, but I get like complete freedom pretty much whenever I want to clock in. I'm on the clock and I don't really have a schedule, so as long as I do my 40 a week, they let me do it whenever I want.
Awesome.
Yeah, so once I get going, I tend to stay going.
I gotcha. Let me see. There we go. Now your beautiful face is just on screen up here by the
Yeah,
plane you
there.
helped you helped
Yeah,
audit.
there I am. Hi, chat.
Mod second mod reveal.
Yeah, second mod reveal. There we go.
True.
This one's yeah more fresh in my mind. So like what I do
Oh,
for a living is
William, you
a
be nice. Revolt Rise is a very handsome man.
thanks, William. There.
Sorry.
What I do for a living at the moment is I like started my own like consultancy doing data acquisition and acquisition systems and like data analysis for like I started in motorsports and like I've branched off into a bunch of other directions. And like one of the companies that I contract with was hired to do the initial simulation for like partially for the FAA and also as like a secondary step in the review process when they were going over what they're going to be changing the FAA's audit process to.
Hmm.
So they wanted to have multiple eyes on it. I think there were five other companies that were each independently tasked with like going through certain data sets and building a model. And then I think the FAA took those models and compared them. I'm not sure whose they ran with or if the decision was ever made public, but that was like, so we went through, I had access to like all of the data from the flight recorders of crashed planes and of the planes that were of like various test planes that had reported or logged issues, and also of the simulation data that they were running at Boeing when they were using their original simulators to test to validate the design.
Okay, so it looks like you had like access to a huge amount of data from these planes.
Yeah. So we worked with like I was part of the group that was like basically going through and running like test procedures. Like when we were doing in building the model, basically like it was my job to go and make sure that like we knew for a fact what certain conditions were and then what the plane did, and we wanted to make sure like I was validating that when we were in the simulation, a certain amount of stick input would get a certain amount of flap and a certain amount of tail and a certain amount of rudder input would get a certain amount of tail movement and stuff like that. So that was like the part of the thing that I worked on. But I also like just like did a cursory like exploration for my own interest about like the electrical system and some of the design parameters that they were using.
Hmm.
And basically like what the analysis came out to be from a technical perspective is that they were using the cheapest possible control units to run the plane. And it was the previous generations of 737 were manual controls. So there was actually like when you're pulling on the stick, you were actually actuating valves that were connected to the hydraulic system. And so like there's actual physical connection there.
Okay.
And this was the first time that they were switching to a fully electronic control, or a partial. I'm sorry, it wasn't fully electronic control. There was parts of the process were integrated with electronics in this new iteration, and so what they were using for a controls like the control box has a certain number of inputs and outputs, and basically they were out of sensors, like they were out of ways to plug sensors into the control unit for data, and so they were like piggybacking into multiple sensors into less inputs than were necessary. So what the result of that was is you had a system where there was a sensor called the angle of attack sensor, and it like basically tells the airplane how high the nose is. Like if you can picture, an airplane flying through the sky, like when the nose is pitched up really high, that's considered a high angle of attack. And when it's
Hmm.
neutral, you're neutral. And when it's down, that's a low angle of attack. And so the sensor's job is to basically monitor where the position of the plane is, because if you pull the nose up too high and ask the plane to try to climb too fast, it will stall out. And so one of the problems that they were having with the designer that they were trying to combat with this MCAS system that they put on it, and the thing that caused all the drama, is that the engines, the new design of the engines that are actually really cool and very efficient and much better, but the engine itself is actually like such a large design and diameter that it needed to be moved way forward from where the original engines were. And so because of that, the balance of the plane was upset such that at full throttle, when you're taking off, the plane had a tendency to try to nose up higher and higher and higher. And if you didn't control it, it would basically nose all the way up until it stalled. And what you get, like in a stall situation, you no longer have enough airflow over the wings to support the plane, and the plane literally just stops flying and starts dropping like a rock. So the system that they installed was basically to monitor the angle of the plane, and if the nose started to get too high, it would automatically nose the plane down. What ended up happening was there was a number of situations, but basically the end result was that they were using, instead of using multiple sensors to cross-check, basically to say like, we've got two different systems basically like to determine the angle of the plane. They thought that they had that, but the way that it was actually wired into the control unit, they weren't getting both, like they weren't accurately cross-checking both. Like basically there was one sensor that would go up in voltage as the angle increased and another one that went down, and they weren't comparing them correctly in the software. And so like the
What
issue
can
overall. Go
I
ahead.
can I ask why was it so necessary for them to have this software system?
So they had to add this software system, and that's a really good question. Like I haven't thought about this enough, and I haven't talked about it enough to really like have my brain organized. So you guys might have to go on a little ADHD ride with me
It's
when we
all
go
good.
through
It's
this
all
here.
good.
But
We're buckled in for safety.
cool. So the software system was necessary because like I was saying, the tendency with the new engines, because they had to change the mounting position, was that the plane would naturally, like during takeoff in high power situations, go into a condition where it would stall. And so like if the pilot wasn't aware of that, if he wasn't paying attention, it would wind up there. So what they were trying to do was make it so that the plane would naturally cancel itself out and never let the pilot know it was doing it. Like picture like an automatic system that automatically trims the um, um, elevators so that the um, plane is never going to nose up, or it won't nose up beyond a certain angle.
I,
But
I
it wasn't part of the pilot's control.
I guess I'm okay. So, but then why would you build a plane that would need this sort of
Yeah, this is where it
this
gets
sort of babysitting in the first place?
this is where it gets good, because it's cheap, because they could reuse the design of everything else on the plane and not have to go through a whole recertification of the design of the airframe, which is
Okay.
like a big deal to do the certification. And so they're reusing as many parts as they possibly could and adding these new engines that are way more powerful and much more fuel efficient. They're called high bypass engines, and basically like it's got a huge fan on the front of it, and most of the fan air goes directly out the back, like it doesn't go into the engine at all. So the benefit of that is that it provides like a massive amount of cooling to the engine, and also it's got ability to like open secondary stages so that sometimes it will catch some of that air and add like an afterburner almost, but
Hmm.
not quite. um Without getting into the technical weeds here, but like to summarize, basically they were trying to be as cheap as possible. And so they found out they realized they were going to have this problem. They knew about it. They planned for it, but it took a bunch more sensors and controls. Like they were only going to run one motor in the rear to control the elevators on both sides originally. And they found out that the like when in practice, the motors that they were using weren't strong enough to be safe at just using one single, and so they had to split it. And so in splitting it, they then were taking up four more pins of outputs on the controls, on the control boxes that they were running for the control units. And in order to make that work, they had to take one of the AOA sensors out of the deal.
This sounds
So
like an
part of
absolute clusterfuck.
it's just one of the it's called the engineering cascade effect, and like it's just shit rolling down a hill. And the other thing that they did that was like the real problem ultimately is that they fired all their middle managers and like hired a bunch of young kids, and then like outsourced most of the software programming to a company in India. And what the result was is that there wasn't one single person anywhere on the project that could see end to end. So you had like the people that were doing the control system,
Wait,
people that were doing the sensor systems.
why would they fire their entire middle management? Like,
But to
just
save money.
save.
This was like
Okay.
this was a corporate decision that was made over a number of years, but this has been like the move that they've been making, and such that like they've got rid of a bunch of project managers and a bunch of like all their higher paid engineers. So they were able to
So
outsource
yeah,
all their stuff to
rid
India.
of their high paid engineers. They got rid of their people who knew what was going on, and it just kept going, huh?
Yeah, and just kept running with it. So the there's a whole bunch of controversy that I really can't speak about, that I don't know enough about what was going on inside of Boeing at that time.
Hmm.
But like everything that I'm talking about, like I've mentioned so far, is available from the FAA, from their like in their report basically. But there was a bunch of other issues that we were able to identify too, like as far as there's certain processes that you use, or certain techniques that you can use to predict failure based on like a bunch of real world data and engineering specifications for things like wiring harnesses.
Yeah.
And like we found a bunch of places where there were bundles of wiring harness that have branches in them, like where the branch would come off of one side of a wiring harness like this, causes a weak spot, and they were just like shaking and they were going to cause failures. So they had to go back, and they ended up having to go back and pull their wiring harnesses apart and like completely redo all these planes. And if you can imagine something that runs from the cockpit to the tail of the aircraft, it's a wiring harness that goes into everything. And so all the seats had to come out, all the panels have to come out. And it's just like, might as well build a new plane at that point, as
Yeah.
far as like efficiency purposes. So they did a lot of that, and they upgraded they've upgraded the control units to a bigger unit that has like 100, went from 128 pins of output to 235 pins of output. So, or inputs and outputs. So now they run double sensors. But the thing that was actually causing the problem when they were crashing was that control sensor was basically outputting hysteresis, like what we call hysteresis. And basically it means it's just that the number was bouncing around, either from turbulent air or crap in the sensor, or something was happening to the signal of the sensor that was making it bounce in a way that confused the computer about what it was doing. And there was a
Oh.
programming error that put that into a feedback loop that basically bricked the computer and just ran in a cycle over and over again, increasing the angle of attack. So, or decreasing the angle of attack, like pushing the nose of the plane down.
Okay.
So you literally had to shut it off. Like, have you tried unplugging it and turning it back on? Like that whole deal.
Mid
And you,
flight while it's going
you
down.
you literally had to, like, and that's what was
That's
ultimately what was causing the accidents. So
absolutely
it was.
fucked.
Yep. And so like there's normally like the sensors that they were using, they specified a sensor that had 4 outputs, so that it has inside of one sensor. And the sensor is just a weather vane. Like if you can picture, I wonder if I have a picture of it. It should be easy enough to find. But it's basically, picture a weather vane, and it's in horizontal position when the plane's flying forward. And then as the nose of the plane comes up, it'll kind of like clock up and down like this,
Uh-huh.
just free floating on the side of the plane.
Yeah.
And that normally it wants to stay neutral and level, like horizontal, like level towards the ground. And so there's 4 sensors on the inside of that all output voltage from like 0 to 1 volt scale, a 2.5 to 5 volt scale, 5 to 12 volt scale, and then a 12 to 18 volt scale, so that you can't confuse the sensor voltages. You can tell them all apart. They weren't even using all 4 of them. They were only using 2 of them, and they were using the 2 lowest voltage ones instead of the highest voltage ones. So it's like just doing that alone was like, we're like just like day 1, chapter 1, page 1, like electrical engineering no-nos.
Okay. This is so much worse than I thought it was.
Yeah, it was a major problem. And the really frustrating thing about it, obviously, is like they outsourced this labor. Like I mean, it came out, I think, in one of the papers, the New York Times. I think they published that like the average engineer at the firm that they were using in India was making the equivalent of $9 an hour. And like, and they had like over 1.5 million lines of code that went into programming all the systems on this plane that company did for them. And the engineers at Boeing were so frustrated with the system. There were just people dropping out like left and right. Like they were losing people were quitting over this job, and it was just a disaster from the get-go, from what everybody has said about it.
Because they didn't have any like input in how this thing was coded,
and
basically.
and and they were just patching errors after like small problems after small problems, like just in like the actual thing when they found out about the motors that control what's called the elevators. And that's like, if you look at a plane, on the back you've got a vertical tail section, and then you've got the cross that comes out the side of the tail on the
Hmm.
rear of the plane. That's the part that controls its pins up and down, and that's what controls the nose direction of the plane. So that's called the pitch.
Yeah.
And so basically, what they were when they found out about that motor issue, like the plane was already like past the deadline, or like it was like right at the deadline for when they were supposed to be like releasing it. And so it was like hurry up and run around and just all this like half-ass stuff and like make new pieces to adapt to two motors, and like it was just like hemmed together in such a way that it was not very confidence inspiring at all for somebody who ride like at the moment. I think I've got over 11 million uh, uh, sky miles through Delta, and like a bunch of them have been on Boeing planes, and I don't think I'm going to put any more on Boeing planes if I can avoid it for a while.
Yeah. Like so like the 737 Max is now coming back. Like
Yes,
it's now been certified to fly again, but you're still not.
I don't. I mean, there's nothing about the operation screamed to me that like it was just do the bare minimum. Like what can we do to get this done? We have to get this plane out. So what do we have to do to get this done? And not what is right, not what is best, what is best practice. So I was just I think I read a couple of days ago there was an article that came out that said that they had to go back and replace those whole harnesses that we identified a problem with, and there was like something like hundreds and hundreds of these problems that were like that the eventually our report like showed that they had. So it's just I don't know. You would think that the FAA would be a lot more involved, and they weren't involved at all. And I'm not exactly sure what the ins and outs of how that went was, but it was pretty rookie. Like all these mistakes are just obvious to anybody that's seen a control system before. You know?
Yeah. I so if I can tie this into capitalism for a moment, um,
Yes, that
like this all of this seems to stem largely from a desire of people at the top wanting to cut costs so that they can make as much money as possible on this deal. Like I imagine that if they had like focused on making this plane as safe as possible, if they had focused on doing the quality job, not outsourcing the code, not like even if they were just still it was still on the the model that they were using, if they had the experienced engineers, if they had the middle management who could see the entire project, that this might not have been the entire clusterfuck it is right now.
Yeah. Oh, yeah. To summarize, like if they had sent this to us, like, or you know what I mean, or asked me, or whatever, to look at this, and just had a picture of end to end of like a wiring diagram and like a system description, like it would have. I don't think
Wait,
I personally would have never ever okayed it for anything. Like I wouldn't run a car like this, let alone an airplane.
did
And
they
like
not have that?
I mean, there was, as far as I know, there was nobody, not one single person, and like, and who knows? They might be saying that now because they don't want to go to jail. But like, I mean, like, there's was allegedly there was not one single person that had an end-to-end view of the whole system.
That's that's absolutely
Insane.
wild. Yeah, yeah.
Yeah,
Uh,
the word you're looking for is nuts, and like, yes, it's
like
nuts.
you don't like you don't design a plane. You don't. I'm just trying to like wrap my head around this. Like it's like you had one guy who knew what the front of the plane was, you had one guy who knew what the middle of the plane was, you had another guy who was working on the wings, and you had another guy working on the butt, and like none of them communicated with each other.
And they were in different countries at different times, and like so the plane design was finished in 2016 or 2017 or whatever, and then they sent the wiring harness design out to be sublet to another company, and then that came back, and then they sent those things to the software company, and then they asked the plane guy, you know what I mean, that was like half of the people that designed the mechanicals weren't there anymore because like I said they laid off all the workers. So
Right.
it's like just crazy. Just crazy stuff.
Yeah, so like again, it's this weird like profit protectionism, I guess. uh
And
yeah.
yeah, well, 100% that they were competing with, like they were behind the eight ball big time because of like let me do two things at once. I can't. What was I gonna say? The competitor, the Airbus A320
Yeah,
had
yeah,
come
yeah.
out, like the A320 Neo came out like a whole year before theirs was even scheduled to come out. So I think it came out in 2018 and theirs was due to come out in 2019. So they were losing market share like crazy. So they had to hurry up, and then they ran into these problems.
Wasn't there also something weird with Airbus, like they lobbied to delay the implementation of Airbus in the United States by essentially getting legislation passed that it had to be manufactured here.
It was bomb. Well, see, that was a different situation,
Different
but
thing.
also very relevant. And like, in this decision, like basically, Airbus or Bombardier, the Canadian company,
Mm-hmm.
had a really cool design for like a small jet that was going to be. It was like a picture, like a in between a big commercial jet and a private plane, like directly in the middle, like something that you might take on like a short connector to get on a real plane to go someplace far away.
Uh huh.
Like they had that whole class of jet. Like Bombardier came out with like basically the best design that anybody had in the market, and like nobody had really been paying attention to that market, and it was happening to just be blowing up at that time. Like it was getting very popular to have these small jets, and a lot of people were looking for them. So the thing of it, Bombardier basically took a like it was partnered with the Canadian government. They took a bunch of investments, but like Boeing petitioned to prevent them from doing business inside the United States because they were gonna beat them, like, you know what I mean. They were gonna take away from 737 sales because these companies are gonna buy smaller jets to run these regional or local flights.
Mm-hmm.
So Bombardier or Boeing petitioned to put it like an import tax on Bombardier, and they couldn't bring them in the country, or they couldn't competitively bring them in the country. So Bombardier and Airbus, like Airbus, gave Bombardier a huge investment and then helped them to set up their manufacturing facility in Georgia. So they actually build the planes in Georgia now, and Airbus is selling them as an Airbus plane
Okay.
through like licensing or whatever. So it worked out good for everybody involved, but except for Boeing. Like Boeing's getting beat up and down. Like they don't have a plane in that market at all. And like then on top of that, they were hurrying to put one together, and then the 737 Max blew. This whole thing exploded, and I've been dealing with that ever since.
Wow.
Yeah.
So I I again, like this is something we've talked about, but like I feel like a lot of these problems would be addressed if this was a worker co-op and the workers weren't viewed as expendable for the profit of the company. Um
Right. Yeah, and that's the whole thing. Is like I'm looking at chat right now, and like yes, like it's Boeing got scared of capitalism, and then we stopped the capitalism from happening. And on top of that, now we've bailed them out. And this is the kind of design stuff that they do. So if you look at this picture, they've got in the link that I shared, they've
yeah.
got the AOA sensor captain, and then the AOA sensor FO, which stands for first officer. There's what side of the plane they're on, the left or the right. And the like those like just the one on the FO side was there on the planes that crashed.
Mhm.
The one that was on the captain side was an option. Like you could buy it, and like when you added it, it upgraded the control unit. This flight control computer right here.
Yep.
It upgraded the flight control computer into one that could actually take all four inputs from both sensors and cross check them against each other and do a rationality check. And basically, like the software could be programmed such that it could say like, okay, this one says that our angle is too high, and this one says that our angle is too low, and it will set an error, and based on what the readings were before that, it will go to backup readings. So it'll do things like it shows here that there's a pitot tube or a pitot probe, and basically that's just like a small hole, and there's an orifice that's a metered size.
Mhm.
And so based on how much air pressure is going into that orifice, it can tell how fast you're moving. So basically they redesigned one of these so that it would check the AOA sensor against the pitot tube. And what they originally weren't doing is they weren't actually cross-checking those inside the software. They were supposed to, but they weren't. It was never done. They were using the pitot tube for airspeed, and they were using the AOA sensor for angle, but they were never saying like, whoa, these two things don't jive. That if we're at this engine RPM, we can't possibly be at this airspeed unless we're at a really high angle. So like that's something that they could have done, but they didn't. That was never done in the software.
So it seems like there are a lot of small ways where this plane could have been made a lot safer.
Yes. So basically, what they needed to do was add the secondary sensor so that you've had the two sensors, and change to the control, like the upgraded control computer. And once they did that, like now you've got double redundancy on both sensors. Like both sensors, you can use two circuits separately inside of each, into two pairs,
Mhm.
basically, so that you've got four failure point. You can have four failure points, and it will still fly. It'll still work as advertised. So like that's one of the things that should have been done. They should have been running like double path electrical, and they should be running double computers, and they should be running simultaneously in case like you have to restart one, you can flip over to the other one while you restart it and
Right.
not actually like disable the plane's controls for a second while the thing reboots.
Have some redundancy.
Yeah, yeah, right. Any basic like education on redundancy or like an understanding of vibration analysis, like which they didn't do hardly any of at all in the wiring harness, and there were just major sections that were unsupported. That like if you let the wires droop between the cable stays that you put up there, and they shake around over time, it embrittles, like it causes embrittlement of the copper, and it causes it to fracture, and you'll end up with shorted wires. For
Um,
all the important stuff like flying the plane.
yeah, I mean, and people died because of these issues, right?
Yeah, I don't know what the death count was, but it was, I think, a couple hundred people in both cases of both planes that crashed. There was one plane that crashed into the ocean and another plane that crashed in North Africa, and I want to say it was in Sudan or Ethiopia, but I'm not sure about that. I don't remember anymore.
Mm-hmm.
And so another thing that was like a major issue, or like part of the reason why they were pushing this, is that like when you come out with a new plane, there has to be a training program, and so like you have to get the pilots used to the systems of the new plane. And there's usually a requirement. I forget what it was. I think it was 20 hours or something like that needed to be done with an instructor in a flight in a like a certified simulator. And in order to do that, the expense that it would cost each airline to do that was going to be in the millions of dollars to send all their pilots to school and then send them to the check ride. So what Boeing was trying to say, like while these companies were ordering up these new Airbuses, they were saying like, whoa, 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 hold on. Like if you buy our plane, like you can keep the same mechanics, like like all the fittings and everything on the outside of the plane stay the same. So the mechanics don't have to buy new special tools or anything, and the pilots don't have to be retrained. And there's a whole bunch of cost savings involved in that. And so that was why there is this whole element of this scandal that is like the pilots didn't know about the system. It's because the pilots literally didn't know about the system. Like nobody told them that it was there or that it was working. On the previous
Cool.
generation plane, the rudder, I mean, the elevators only move when you pull the stick, so
Right.
or like you're pulled on the yoke. So they're pulling on the yoke and getting no results, And the plane. So in the
That's
cases that it
wild.
crashed, and there was quite a, I think there was a total of 26 like incidents that Boeing had flagged, but like, I could be wrong on that number, so don't quote me. But like 26 incidents where they had data that was like a problem for this system is that these pilots got basically scared shitless, and the ones that didn't crash all figured out like master on, master off, and master back on again, and like then
Yeah.
started flying the plane, and that's just like very frightening.
Yeah. You don't want them doing that mid-flight.
Right, right. And so like what the picture is on in the center of the picture, there's a thing called the control stand. And you see the manual stabilizer trim wheel.
Mm-hmm.
And basically like based on the loading of the plane and in various different circumstances that you'd be flying the plane like into like like whether you're into a headwind or into like a crosswind or whatever, you can, and it's typical to put some adjustment on those. And even if you're like ascending or descending for a long period of time, like just slowly trim that, and that wheel controls the elevator in the rear of the plane. So what was happening was like the pilots are seeing that wheel just spin forward and basically be like trim adjusting up, and they were like trying to physically stop the wheel, of which no longer has any physical connection to the system in the back.
Right.
So that was part of the problem, that like they were fighting. There's, I guess, the pilots were fighting with each other about what to do about it, and like losing time, and the whole while the nose of the plane is just pointing down towards the ground, and they can't pull it up.
Um. So, I saw Hypertroller in chat talk about literally how would keeping workers on have prevented this if they're not like if they're shit workers. But I don't think the workers that got fired because they were shit. I think they got fired because the company was trimming money. They wanted to pay workers less. They wanted less trained
Right.
workers.
Well, they fired who Boeing laid off were all of their like middle management or people that had like seniority, so they were the highest paid workers that they could, and they just left the younger and inexperienced people basically. Is the sad but true fact.
Yeah. And I'm sure outsourcing to a firm that does coding for $9 an hour probably also didn't help. Um, By the way, I also saw it mentioned in chat, like the coding, like the double coding. What was that about? Or some more issues with the coding? It was a while ago, so
I didn't see it fly by. But if anybody wants to ask a question again, I'll gladly answer it if I can.
yeah,
216. Oh, nice, Hyperjoy. 216 complaints.
yeah. Like what? So what does that mean, by the way? Like a complaint with the FAA?
Complaint with the FAA is basically there's a procedure for there's multiple systems that overlap. There's a lot of redundancy, and I'm not a pilot, even though I play one in real life sometimes. But like I really am not a pilot. The So I can't tell you for 100% sure what the actual procedure is. But the theory is that whenever there's an issue with an aircraft, whether it like any kind of performance issue at all, whether it's something major like an engine explodes or like something very small, like like pilots were losing communications between the two seats on their mics. You know what I mean?
Mm-hmm.
There's a reporting procedure that when you make the report, it goes to Boeing and to the FAA at the same time, and there's no way around that.
Okay.
And so like those complaints where these pilots coming in and telling the mechanics basically like, hey, there's something wrong with this plane, or I got a warning sensor for an AOA failure, or blah 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 blah.
Yeah.
The one
Jeez.
speaking of which, I just talked myself into another like point that I want to bring up.
Yeah, go for
Like
it.
one of the other things that they failed to do is there's no warning light or anything like that to indicate to the pilot that this system was engaged, right? Because they didn't want the pilots to know about it, I think. But we can't be sure why. But it would have been so simple if there was just like a AOA failure light that lit up on the dash that
Yeah.
literally could have been like, you know what I mean? That's all it would have taken, and the pilots would have instantly known, like, oh, okay, like now we've got an issue with like it not reporting the right angle of attack. The reason why that's important is because like the failure mode that this went into, even if this software error hadn't been there in the first place, it easily could have caused many crashes over time without anybody knowing why, because the plane could have been nosed down just very slightly, and over a long enough period of time, if the pilot was thought he had the autopilot on and didn't realize that he was descending for what I mean because of a sensor failure, he would basically just fly the plane into the ground. Like
Right.
if if it was nighttime and you were over the ocean, there's nothing to see, there's no light or anything to tell you that you're getting close to the ground, and boom. Like so there's just like the most fundamental systems in the world were completely overlooked in the course of this project, and it just seems like such a ridiculous waste to me.
And like it from where you're standing, like after your audit, it does not seem like they've addressed nearly enough of the issues for this plane to be something you would want
I'm
to fly on.
they haven't exactly said what they did, but the list of things that they've claimed that they've done is not nearly as long as the list of things that we recommended that they did. And it's not that like maybe we were being over, you know what I mean? Like there's some there's some trade-offs in everything, you know what I
Right.
mean? Like they can build an airplane that will never ever crash ever, and it'll, you know what I mean? And it will like be completely safe with quadruple redundancies, but it will cost $100 billion and you'll never be able to afford a ticket. So like there has to be some trade-offs.
Right.
So, so I can't say for sure, but I mean, I want to see a 10-year service record on these things before I put my ass in one of those seats, to be honest with you.
Okay. So you can fly, just maybe use some caution when it comes to the
Well,
737 Max.
and it's easy to tell. It's easy to tell now because if you use Google Flights, they'll tell you exactly which kind of plane you're going to be on, and just avoid them if you can.
Yeah.
I mean, it's not. I'm sure that they're probably safe, but I don't. I'm not going to put my ass in a seat on one of these planes. I promise you.
Oh, I think that's some valuable data to have, considering you're one of the people who audited this plane.
Yeah, and like I said, like I'm pretty proud of the fact that I'm over 11 million sky miles, so I've been in a lot of airplanes.
uh, were you flying on airplanes when you were captaining that tuna boat?
No, no, that was that. Like when I was captaining that tuna boat, I had no idea that I would end up in Texas and working, flying around the country and the world chasing race cars. It was only a dream at that point, which I had plenty of time to think about it because it was a 2 day steam out and a 2 day steam back at 9 miles an hour on the world's worst damn boat.
Well, thank you very much for coming on and just talking about this. It was great seeing you like pop up in chat and being like, "Oh, I know about this plane."
Yeah, I can answer a million more questions too. It's just like trying to tell the story and think about all the things I know about it and organize them on the fly with my dog nipping at me because he wants to eat and go outside is different.
Aw. Hypertroller wants to know what other planes would you recommend that are out there?
The A320, the A320. I mean, would I recommend? I'd say an A350 if you got if you can find one that's going where you're going. You want to get on the new A350s. They're baller. I would like because I had like at the time I was close to diamond status with Delta. I was able to get first class seat on their like initial like maiden flight to France
Oh,
from
cool.
Chicago. Yeah, it was very cool. And they're baller as hell. Like you have like your own little like apartment basically when you go on the plane.
Awesome.
Yeah.
Um, all right. Well,
But what plane would I recommend? Get on an older like it'll say 737 Max. Like don't do those. 737 Neos are fine, or 737 new generation ones are fine, and the ones any of the Airbus planes or a Bombardier plane is fine.
okay. A plane for us plebs.
A plane for the plebs.
Exactly.
Yeah. Yep.
Well, I'm gonna let you take your dog outside and feed him. Okay.
Yeah, I got both of them. I was gonna try to show you, but they're already jumping on me. I'll come back later. I'll put
Okay.
pictures in chat.
Yes.
See you
Put
guys.
pictures up. See ya.
Thank you.